Hi there, my name's Ken Stafford. I work as a maths tutor. I also run a few maths-based websites, one of them being mathslinks.co.uk, and one being a personal website for myself for my maths tuition. When I was putting together mathslinks.co.uk, I came across the Naiker website, lots of really good sheets on there, but not all the solutions. So I started creating the solutions as a PDF, and I've decided to start filming me doing them, so they might be useful just to watch these videos as a way of understanding how to solve these questions. So this video is about forming and solving an equation. Forming an equation is obviously harder than just solving it because people get confused about how to form it. So I'm going to try and explain how you form equations. This first question, question 1, is about an isosceles triangle. And an isosceles triangle is a triangle where two sides are the same length, and that's indicated by these hatchings to show that those two sides are the same length. It's also shown by the fact that this side and this side are 2x. Okay, so to form an expression for the perimeter, well, the perimeter on any shape is just add all the sides together. So we're going to add together the three sides. So that's going to be 2x plus 2x plus 10. And we can simplify this because 2x plus 2x is 4x. So the overall expression for the perimeter is 4x plus 10. And that just means 4 times an unknown number plus 10 is the perimeter. In part B, we're told what the perimeter is. So in this second bit down here, we're told the perimeter is 34. So we can say our 4x plus 10 from earlier is equal to 34. So that 4x plus 10, our expression for the perimeter. So an expression is just using letters and numbers. You can't solve an expression. You can solve an equation. And we now have an equation because we know the perimeter is equal to 34. So we can say 4x plus 10 equals 34. And then we need to solve this. By solving this kind of linear equation, we want to make x the subject. So to get rid of that plus 10, we take away 10 from both sides. And then to find out what 1x is, we divide our 24 by 4. And we get x as 6. Now we can always check if this is correct. It would mean that the sides that are the same length are both 12 because they're 2 times x. 12 add 10 does give us 34 centimeters. So then we know we've done it right, and we can be happy with that. Okay, so question 2 now. Similar to what we just did, apart from the fact that this isn't an isosceles triangle, it's a scalene triangle. All 3 sides are different. I'm going to expand the brackets for the red sides. So that's 3x take away 9. And we get add that on to 2x plus 5. Perimeter is always adding the sides together, and then we're going to add on the final side, which is 4x minus 1. And we're going to collect up these terms. So we've got a positive 4x, positive 2x, so 6x, and then a positive 3x. So overall, there are 9 x's. I'm going to do the same with the numbers. Minus 1 and minus 9 make minus 10. Add 5 takes us back to minus 5. So that's our expression for the perimeter. We've added together the 3 sides, and we've got 9x minus 5. In part B, we're told the perimeter is 49. So we can say 9x minus 5 equals 49. We formed an equation. That 49 came from that. To solve this, we're just going to make x the subject. So we're going to get 9x by adding 5 to the left. So we have to add 5 to the right. And then to find what 1x is, we're going to divide that 54 by 9, which is 6. So x equals 6. We can go back and check that that works by substituting it into the 3 sides and seeing if we get 3 lengths that add up to make 49. I would always recommend doing that just to double check you've done it right. Question 3 here is very similar. It's about perimeter again, but this time it's a quadrilateral, which means it's got 4 sides. And we're asked to find an expression for the perimeter of the quadrilateral. So nothing changes here other than we're adding four sides together. So in terms of collecting up the like terms, we're going to add up the r's. There are, let me pick a nice colour. We've got 2r plus 2r is 4r, plus another 4r is 8r, 9r. And then we're going to add together the numbers. There's a -5 and a -3, which make -8. So our expression for the perimeter is 9r minus 8. We're then told the perimeter of the quadrilateral is 65. So again, we're just going to form an equation and solve it. So we're just going to say our 9r minus 8 is equal to that 65. This 65 came from here. And I wrote 64. So that should say 65. To solve this, again, it's a linear equation. A linear equation has got just a letter to the power of 1. We obviously don't put the power of 1, but it's implied. To solve a linear equation, you always just make the letter the subject, in this case r. So we're going to add on 8 to the left to get rid of -8. So we add on 8 to 65, which gives us 73. And then we're going to figure out what 1r is. 73 divided by 9. And 73 divided by 9 is 8.1 recurring. Feels like a weird answer. I would be double checking to make sure I've done everything right, which we have. Just one of those questions where we've got a weird answer, a recurring decimal. Okay, question 4 here. Different because we're looking at angles now. So we need to know a certain fact about angles in a triangle. We need to know that the angles in a triangle sum to 180 degrees. So they add up to 180 degrees. That's going to be really important. And that's how we're going to form our equation. So we're going to add together the 3 expressions for the angles. So we've got 2x, 2x, and 1x. So we're adding them together to get 5x. And then we're going to do the same with the numbers. We've got 7 plus 18, which is positive 25. So that's an expression for the 3 angles. To make it an equation, we have to put it equal to something, and we know that those angles are equal to 180. And in part B, we're just going to solve this. So we're going to say 5x plus 25 equals 180. Therefore, 5x must equal 180 take away 25, which is 155. And then x is 155 divided by 5. So x equals 31. And we can always check that works by substituting back in. That would make this 62. It would make this one 49. And it would make this one 69. And if we add those 3 angles up, we should be looking to get 180, which we would. And then we can be confident we did it correctly. So whenever you're solving an equation, you can always substitute back in to check if you're right. And that's a really useful skill to have and something to always try and do, particularly if it's a test or exam. Okay, question 5, almost identical to the last one. We're adding together 4 angles, and this time they don't add up to 180. Angles in a quadrilateral always sum to 360 degrees. So in a minute, when we write our equation, we're going to put the sum of these 4 angles equal to 360. And we're just going to add together the angles. We're told them here. So we've got x, 2x plus 2x. We've got 5x's. And then if we add together the numbers, we've got 50 and 10, so 60. So that's our equation. Our equation is 5x plus 60 equals 360. And I'm sure in the next part it's going to ask us to solve it. Yep, so part B here, we're solving this equation. Simply get 5x as the subject by taking off the 60 from both sides. And then we find 1x by dividing 300 by 5. 5 goes into 36 times, so it goes into 360 times. And a nice answer like 60 feels like the answer, and we can always check we've done it right by substituting in again. Question 6, we're back to questions on perimeter. It's a parallelogram. So we're going to write down an equation in terms of x, while we've got this side x plus 4, and we've got this side 2x minus 1. And if we add those together, we haven't got the full perimeter because there's another x plus 4 and there's another 2x minus 1. But if we wanted to, we could say they're equal to 12 because it's half of the perimeter. So that would mean our equation is 3x plus 3 equals 12. If we did the full perimeter, it would be 6x plus 6 equals 24. 24 came from there. The 12 came from halving the 24 because the first time I did it, I only used two sides, so they would add up to half the perimeter. And now we're going to solve this equation. It doesn't matter which one we solve. If we solve 3x plus 3 equals 12, we get 3x equals 9 and 1x equals 3. If we had formed our full perimeter, we would have got 6x equals 18, and again 18 divided by 6 is 3. So either way we do this, it doesn't really matter. X is equal to 3. Question 7 here, simple perimeter one. We've got 3 sides and they all feature the letter T, so we can say 3t if we collect up all the t's, and if we add up the numbers, we got 4 add 3 and minus 1, so positive 6. That's an expression for the perimeter. We can put it equal to 19 because we're told the perimeter is 19, and we can just solve it. Take away the 6, 3t equals 16, and then divide that 16 by 3, and we get 5 1/3 as a mixed number, or 5.3 recurring, whichever one you prefer. Always makes me feel a bit nervous when I get an answer like that, but I'm looking back at my working out and I can't see anything I've done wrong. So that must just be the answer. Question 8, so we're just sort of practicing things we've already done. 3 angles in a triangle add up to 180. So in collecting up the like terms, the expression for the 3 angles is 6x plus 30. We can put them equal to 180, and then we can solve. So x equals 25. One more question left. Question 9, y is 4x plus 1 equal to 2x plus 12 because opposite sides of a rectangle are equal. So opposite sides of a rectangle are equal in length. And that means if we solve this equation now, we can figure out what x is. So first step here, get all the x's on one side. I'm going to get rid of the 2x on the right, so it means I have to take away 2x from both sides. I then need to get rid of the 1, so I take away the 1, and then I need to divide 11 by 2, which is 5.5. Now that we know x is 5.5, we can figure out the perimeter. This side is 5.5, as is this, and these sides are 23. If we substitute in 5.5, that means we've got 23 plus 23 plus 11. I've added together the 5.5 and the 5.5 to get 11. So that's 57 centimeters for the perimeter. So this sheet is available to find in the description, as is the solutions, which I've been filming myself doing. There's more sheets like this on my website. Links to my websites are in the description too. Hopefully you found it useful. Thanks a lot.